Hey guys, welcome back. So in the last video, we saw how to create a blank binary tree. Hope that concept was clear. Now in this video, let's see how we can traverse all the nodes of a binary tree. So let's say this is our binary tree and we want to traverse all the nodes in this tree. So what are the options that we have? So in total, we have 4 options in which we can traverse a binary tree. So the first option is pre-order traversal, second is in order, third is post order, and finally level order traversal. Now let's see each of these traversals one by one. So the first type of traversal is the pre-order traversal. Now what do we do in pre-order traversal? Very simple. We first visit the root and then we visit the left subtree and then the right subtree. So for example, if we want to do a pre-order traversal of this binary tree, how do we do that? Simple. First we have to visit the root, which is 20 in this case, so we put 20. Then we have to visit left subtree. Now we have to put a left subtree here. And then we will visit the right subtree. So we'll put right subtree here. Now what is left subtree? Left subtree is basically this subtree over here. And the right subtree is this subtree over here. Now the question is, how do we traverse this subtree? So the answer is simple. The same rule as we have applied here in case of the original tree, the same rule again will apply for this subtree as well. That is, first we will visit the root, then left subtree and then right subtree. Now what is the root of this subtree? It is 100. And what is the left subtree of this root? It is this subtree over here. And the right subtree is this one for 100. So what we put over here is 100, which is the root, and then we have to traverse the left subtree and the right subtree. So we put brackets over here because we will come to that little later. Fine. Now let's traverse the right subtree of the root 20, which is this subtree over here. Now how do we do a traversal for this subtree? Simple. Again, this node over here is the root and this is the left subtree and this is the right subtree. So we put over here as 3, which is the root. We put a bracket indicating left subtree and one more bracket for right subtree. Now what is the left subtree over here? This is number 250. Now since it does not have any more children, we can put 250 over here. Because there are no children, only 250 is the root, so we put 250. Similarly, here we put 35 for the right subtree because it does not have any children. So 35 is the only thing that we have to print. So we put 35 over here. Fine. So now the right subtree work is done. Now we'll come to the left subtree. So the left subtree was having root as 100 and these two subtrees over here. So we have already put 100 over here. Now let's evaluate the left subtree. So what is the left subtree? The left subtree is this one, 50, and it has got again a left subtree. So we first visit the root, which is 50. So we put 50 over here and then the left subtree. Now the left subtree is 222. So we put 222 over here. Now what is the right subtree of the tree rooted at 100? So if you see this diagram, the right subtree is 15 for root 100. So we put 15 over here. So this is how we have successfully done a pre-order traversal of this binary tree. So what we see here, it is 20, then 100, then 50, 222, 15, 3, 250 and 35. Fine. Now let's see how does the algorithm for this traversal looks like. So the algorithm is very simple. It says pre-order traversal and it takes root as an argument. Then it says if root is equal to null, that is if there is no tree, then simply return an error message that there is no tree, hence it cannot do anything, there is no question of traversal. Else, that is if there is a root node, then what to do? Then simply print the value in that root node and then do a recursive call on left subtree and then a right subtree. Fine. Now let's try to understand this algorithm once again using this stack. So if we run this algorithm on this binary tree, the root's value initially is 20. So it says if root equals to null, no, it is not null, else print root. So it prints 20. Then pre-order traversal root dot left. What is root dot left? Root dot left, that is 100. So it needs to traverse this. So before doing that, since it will go into recursion, what it will do is it will push the next statements into a stack. So what is the next statement? Pre-order traversal root dot right. What is root dot right? Root dot right, which is 3. So it will push this 3 over here in this stack, indicating that once we are done with this call over here, it has to return to this argument 3 and do a recursive call on that. Fine. So now when we are calling this pre-order traversal with root dot left, we are basically giving the argument as 100, which is root dot left. So this algorithm again gets called for 100. If root equals to null, no, else print root. So it will print 100. Then it will say pre-order traversal root dot left. Now what is root dot left? Root is 100, root dot left is 50. So it will again call this for 50. But before that it has to push the next statement into the stack, which is pre-order traversal root dot right. Now what is root dot right? Root is 100, dot right is 15. So it will push 15 over here in the stack. Now it goes on and execute this statement, which is pre-order traversal root dot left 50. So right now root's value is 50. Is it equal to null? No, else print root. So it will print 50. Pre-order traversal root dot left. Now what is root dot left? 222. So it will again call 222. Before that it has to again push this into stack. What is that? Root dot right. It has null because there is no more node over here. So it will push null here. Now again this gets called for root dot left 222. So root's value right now is 222. Is it equals to null? No, else print root. So it prints 222. Pre-order traversal root dot left. Now what is root dot left? There is no more child over here. So this is null, this is null. So before calling this null, it will push this pre-order traversal with a null value again in the stack. Now it will call pre-order traversal null. So the root's value right now is null. If root equals to null, yes, then return an error message. So it does not goes into this recursion anymore. So it is done. Now since execution of this line is done, system will come back to stack to find out what is the next execution statement. It says null. So it pops out this null from here. So root's value is null again. If root equals to null, yes, return error message. So this will not be executed and it is done. So system will again come to stack and see what is the next thing to execute. It will again see a null. So it will pop out this. This null will again be root. If root equals to null, yes, return error message. Then it will not come to this else statement. So again system goes to stack, what is the next thing to execute? 15. So it will pop out 15 and root's value right now is 15. If root equals to null, no, else print root. So it will print 15. Pre-order traversal root.left and root.right. Now root.left is null and root.right is also null. So before executing this, it will push this null value into this stack. So stack is having null right now. So this null is gone, this null is gone, this 15 is gone. Pre-order traversal root.left null, root is null right now. If root equals to null, return error message. So it will not do anything. Then it will again come back to stack, see what is the next thing. It is null. It will put this null into root. If root equals to null, again it will return an error message and it is done. So this null is popped out. Now what is there in the stack? 3. So it will pop out 3 from the stack and say value of root is 3 right now. If root equals to null, no, else print root. So it will print root, which is 3. Pre-order traversal root.left. Now what is root.left? Root.left is 250 and root.right is 35. So before executing this 250, it will have to push this 35 in the stack. So it pushes 35 in the stack. Now this function will again be called for parameter 250. If root equals to null, return error message no, else print root. What is root? 250. So it will print 250. Now what is root.left? It is null because 250 does not have any left subtree, neither it has a right subtree. So both of this will be null. So again, of course, it will be pushed into the stack and popped out, but again there will be no result for that. Now once 250's work is done, system will again come to stack and see what is pending. So 35 is pending. So it will pop 35 from the stack. Now root's value is 35. If root equals to null, no, else print root. So it will print 35. And then root.left and right both are null, so it will not do anything. So we see this is our pre-ordered traversal 20, 100, 50, 222, 15, 3, 250 and 35, which was exactly same as we have seen in our previous slide. Fine. So I hope you have understood how to do a pre-order traversal in a binary tree. Now let's see what is the time and space complexity of this algorithm. So checking if the root is equals to null or not is a constant time operation. Returning an error message is a constant time operation. Else is a constant time operation. Printing root's value is a constant time operation. But here we have a small challenge. So as we have seen in our recursion chapter, that whenever we have a recursion, we typically use a back substitution method, whereby we assume some time complexity of the entire algorithm, and from there we try to derive the base case and equation 2, equation 3, and then we solve those equations to arrive at our final time complexity. So if we apply the same back substitution method, we get the time complexity of order of n. Now how do we get that order n from here? Please see the recursion chapter. We have talked about it in lot of details. Now the space complexity is also order of n because it uses an internal stack which we just saw in our previous slide, and in that stack we typically insert all of the nodes of the binary tree. So the space complexity becomes order of n, where n is the number of nodes that we are inserting in that stack. Fine. So I hope you have understood the entire concept of pre-order traversal. Now in the next video, let's talk about the next type of traversal, that is in order traversal. Thanks for your time. See you in the next video.